In this video, I will explain how the C++ compilation model works and how declarations allow us to split our code between different files or use code from another file. So, I have already written a simple function here that just does addition. It takes two integer arguments, x and y, and it has a return value that is also an integer and is the sum of x and y. Here in the main function, I call the mySum function with arguments 2 and 3, so I'm expecting to get the value 5 out of it. And here it is. We are seeing 5. Now, what if we wanted to put the mySum function below main? Here goes. When I try to build, it's not going to work. And the reason is the mySum function is just not found. So the C++ compiler does not look ahead when it meets an unexpected name. So this is a major difference from Java, C#, and others. So here it actually matters in which order these functions are in the file. But having to put this function always above any other function that might want to use it is inconvenient, and it's also impossible in some circumstances. So you could have two functions which occasionally need to call each other, and then there would be no correct order you could place them in. One of them would always be above each other, and it just wouldn't work out. Likewise, if you had a function that calls itself, a recursive function, then the recursive call here in the code would come before the definition of the function is complete, so that would also confuse the C++ compiler. So to fight this, we use something called a declaration. This here is a definition. So this defines what the function actually is and what it does. And I'll move it here, which, as we saw before, breaks the build. But I will add a declaration out in front. So a declaration is basically the prototype from here, and a semicolon. So from the declaration we can see the types of the arguments. We don't even need to have the names in there if we don't want to, and the name of the function itself and the return type. And the function of this declaration is to tell the compiler something like this, a function like this exists somewhere. The definition will be found eventually. And then the compiler takes it by faith and just assumes the definition will be found. And we can now run this, and it builds and runs just fine. So the main function gets compiled first with the assumption that a mySum implementation will be found later. But the declaration here does not merely allow us to rearrange code within this file. It also allows us to use code that is located in another file entirely. So now that we have the declaration here, we could take our mySum function and we could put it in its own file, and we're going to do just that. So we add a CPP file in the project. I will call this sum implementation, and I will paste in here the actual definition of the function. In main, we no longer have the definition, we just have the declaration. And we'll try to run this successfully. So what if the declaration lies and there actually isn't going to be a function exactly like this? So what if here in the declaration we claim that there is a function mySum that takes a float argument and an int argument and returns int. It's a very small difference, but it will break our build. And now observe that the error we get is a linker error. It's not a compiler error. And what does this mean? What does this linker do? Now we have two separate C++ code files. Each of these files is a compilation unit. So this file by itself gets compiled, and then this file by itself gets compiled. And after all the compilation units are compiled, the linker goes through them, and for every declaration like this that promises there will eventually be a definition of this, the linker will try to find the compiled implementation of the definition. And if it's not successful, then we get a linker error. So linker errors always mean that some of these promises were not kept. Now I'll restore this to be correct so that our project is compiling again and linking. Now suppose we had way more functions than this. Suppose we had 30 of them here in the file, and we would then have to have 30 of these declarations in every file where we want to use those particular functions. And that would be ugly, having all of the 30 declarations here and in every other file. And it would also increase the possibility of making some mistakes. So it would be much more convenient if we could have all the declarations of the stuff in this CPP file, and we could have all those declarations automatically copy-pasted into the files where we might want to use those functions. And that is exactly what include statements do. They take a file and they copy-paste all of the contents right here. So everything in the vector header, for instance, is actually placed here in our main CPP file before it goes through the compiler. And we can just peek in here real quick. The standard headers are very hard to read, but this is basically all a bunch of declarations. And definitions. So we'll make our own header file next, even though right now we only have one declaration. But we could always make more. So we want a header file, and I'll call it sums.h. Here it is. And then I'm going to go to our main file, get our declaration, stick it here instead, and then I will include the header file. Here we have quotation marks instead of the angle brackets because it's our own header. One thing I forgot to put in the header is this first line, pragma once. We would not actually need this right now, but it's a good practice to put it at the start of every header. What it does is it prevents compilation errors from accidental double definitions. And with this we have refactored our program. So we have a separate implementation file for our function and we have a header. That's it for this time.